To start the trig identities that we're going to be working on today, this is section 3.3, I'm going to direct you to the back page of your packet, the very last page, because you have some basic trig identities on that page. We have the quotient identities. These things you should be sort of familiar with. Tangent is sine over cosine. We talked about that when we first introduced tangent. Cotangent is cosine over sine. Those are the quotient identities because it's a trig function that can be written as a quotient. A trig function divided by another trig function. Then we have the reciprocal identities, the trig functions that are reciprocals of each other. So cosecant is 1 over sine. Sine is 1 over cosecant. They are reciprocals of each other. Secant is 1 over cosine. Cosine is 1 over secant. And cotangent is 1 over tangent. Tangent is 1 over cotangent. They can be written both ways there. Those are the reciprocal functions. Then we have a few other ones that we're going to use, and these are the Pythagorean identities. They're called the Pythagorean identities because they're based off the Pythagorean theorem. If you remember when we first started talking about our unit circle, back on the unit circle, I've drawn this picture a couple times, and we had theta in there where this was an angle at the origin and could be any angle. We figured out that x represents cosine and y represents sine, and so Pythagorean theorem says x squared plus y squared equals 1, leg squared plus leg squared equals hypotenuse squared. Well, if x is in cosine's place and y is in sine's place, it could be cosine squared plus sine squared equals 1 squared as well. And that's where our first Pythagorean identity comes from. Cosine squared plus sine squared equals 1. That's why it's called a Pythagorean identity. It's based off the Pythagorean theorem and the unit circle. Now, that Pythagorean identity, I'm going to start here before we get into our actual notes. This Pythagorean identity can be written in a couple of different ways by just doing a little bit of algebra. For example, if I subtracted sine squared from both sides, I would get cosine squared equals 1 minus sine squared. I want to touch on that a little bit. I suppose I should talk about that before we go too much further. This cosine with the little squared, we read that cosine squared, sine squared. That's the same as cosine theta squared plus sine theta squared. They just write it with it in between, because they don't want you to confuse, is the angle the part being squared or is the cosine the part being actually squared? Well, the cosine's the actual function, and the cosine is the part that's actually being squared. So this is how they write it. Anyways, we said cosine squared plus sine squared equals 1, a Pythagorean identity. We could convert that into cosine squared equals 1 minus sine squared, and likewise, I could subtract the cosine from both sides, and I could rewrite this as sine squared equals 1 minus cosine squared. Now, what we do with our identities are things that are equivalent to other things, and what we're going to be working on is rewriting a trig expression or a trig equation and manipulating it and working our way through it until we get both sides of the equation to look exactly like each other. So we're going to be using all of these identities. And I'll give you some tricks to look for, but this is one of those things where there's not one magic way to do this. There are multiple ways to do these problems, and you will find that sometimes they're going to come real easily to you, sometimes you'll see them really quick, and sometimes you get started and you seem to be going nowhere, and you might have to erase and start all over again. The identities that I set up shouldn't take any more than 4 steps, and I guess I'm kind of jumping the gun on that a little bit. I'll bring that up again in a little bit, but it's a lot of manipulation and takes a lot of knowledge of how to work through rules, fraction rules, common denominators, simplifying, doing some algebra, all that kind of stuff. Well, speaking of the algebra, this main identity, Pythagorean identity, has other variations as well. Tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. And I'm just going to go through how they got this first one here. So if actually, it'd probably be easier for me to show you Yeah, I think it's going to be easier for me to show you this next one. It's just easier for me to show you how they got that, the cotangent squared plus 1. It's the same concept for the tangent squared plus 1, so you'll see it, and I'm not going to go through the proof of both of those. But this is just a variation of the cosine squared plus sine squared. Remember, in math, you can divide both sides by the same thing, an equation. You can multiply both sides of the equation by the same thing, as we did here. You can subtract the same thing from both sides. Okay, so what they did to get the cotangent squared plus 1 equals cosecant squared using this original Pythagorean identity is they divided the original, everything in the original, they divided by sine. So they wrote cosine squared, I'm going to jot that down, they wrote cosine squared plus sine squared equals 1, and they divided everything by sine squared. And hopefully you'll see this kind of come together. Well, what's cosine over sine? Cosine over sine is cotangent, so cosine squared over sine squared would be cotangent squared. What's something over itself? 1, so sine squared over sine squared is 1. That's how we get that second part. So cotangent squared plus 1. And then the last part is 1 over sine squared. Well, 1 over sine is cosecant, so 1 over sine squared must be cosecant squared. So that's just another variation of that function. Now, these also have, you can do a little algebra and manipulate these as well. So like this first one I could write as tangent squared equals secant squared theta minus 1. So tangent squared theta equals secant squared theta minus 1. I just subtracted the 1 on both sides. And I could also do 1 equals secant squared theta minus tangent squared theta, subtracting the tangent on both sides. We hardly ever use this one, so I'm not even going to push that one. But on occasion, we might do one like the tangent squared equals secant squared theta minus 1. Likewise, on the cotangent squared plus 1, I could do cotangent squared theta also equals cosecant squared theta minus 1. Now, all I did here is give you kind of a little taste of what we're going to be doing. I manipulated an equation. I manipulated an equation into a different form. And I'm going to be doing that at a much higher level when we work through the problems. So I know I've already spent 8 minutes kind of going through just these identities, but these are the identities that we're going to use. So you're going to find yourself flipping back and forth and as you work through these problems. So let's start on the next page, problem number 1. What's our goal? When they say verify an identity, what they want you to do is verify that these two sides of these equations are equal, that they are the same. And to prove that they're the same is you want to make one side look like the other side. You can work off of or adjust or change the left side. You can change and work with the right side, or you can change and work with both sides as you work through these problems. When I'm verifying an identity, there isn't one exact right way to do it. I just kind of look at it, eyeball it, and I kind of think of what can I do to make this easier? Well, when you're new at it, one thing you want to maybe try to do is get everything in terms of sine and cosine. And this is not something that you have to do. I just want to just suggest this is something that you can do. And there are going to be, especially as a newbie to this, as somebody who's first starting this is kind of what I recommend that you do. Get everything in terms of sine and cosine, and then as you get better, then you can start working with the other trig functions. Okay, so if I'm getting everything in terms of sine and cosine, if I notice on this equation, my right-hand side of the equation is already in terms of sine and cosine. It's got cosine over sine squared. The left-hand side is the one that I want to manipulate. So I'm going to take that secant. Secant is 1 over the cosine. And then the tangent squared. Tangent squared is sine squared over cosine squared. And then the other side, I'm going to bring that down, and you need to. You can't just ignore it. You need to bring it down, and then you need to look at your two sides of your equation. I didn't touch anything, I didn't change anything, but I'm still moving it down. I should have an equal sign all the way down my paper. It'd be nice if your equal sign lines up, but sometimes you don't plan well, but there should be an equal sign all the way down. I'm going to still work on this left-hand side of this equation. I'm a manipulator. I'm manipulating the math. I'm doing the rules. I'm doing things that are legal for me to do. So the next thing that I'm going to do is I'm going to divide this. I don't divide a fraction. What do? I flip and multiply. So this is like 1 over cosine x times cosine squared x over sine squared x. And so I flipped and multiplied. I'm just doing math. I'm just mathing my way through this. That's the same as the other side, which I haven't changed. It was already in terms of sine and cosine. I'm going to leave it like that. They don't look exactly the same yet, but I do notice that I have a cosine on the top and on the bottom. I actually have 2 on the top and 1 on the bottom, because remember, this is cosine x squared. That means cosine x times cosine x. So if I take a cosine x out of both of those, I'm going to change my color so I can write that. Cancel a cosine x. That leaves me with 1 cosine x on the top. So I'll write that as cosine x. I didn't touch the bottom, over sine squared x equals cosine x. Now they look exactly alike. Once they get to that exact like position, I am done. I have verified my identity. I used all of my math skills and my knowledge of what each of these things mean, and I worked my way through to get them to look exactly the same on both sides. That's my goal. That's verifying an identity. It is not something that comes very smoothly to everybody right away. Sometimes it takes a little time, and sometimes you're going to have to think about what options you have. So you've got to go back, dig back into that arsenal of all that math you've done throughout the years and get over the fact that these aren't numbers. We're working with these different looking functions, okay? Watch a few and then see if you can follow what I'm doing. I'm just going to give you suggestions. It's not my way or the highway. If you see something else that you can do, as long as it's a legal math move, you can do those. End result is that they look exactly the same in the end. And that means that 2 people could do the same problem, and they could come up with an end result that looks different, but for them, each side of their equal sign looks the same. Depends on the method that they used or the rule or the steps that they followed. Okay, so I'm going to start this next one. Now, if I look back, I see this secant x minus 1. I want to look back at my identities, and I feel like I saw something like that. I see, secant, I can't use this one because this is secant squared x, or secant squared theta. And so on this problem, because this is not squared, I can't use that identity. But I can rewrite secant as 1 over cosine. And then on this other side, I can either leave it as is, or I can do a step that breaks apart this fraction into 2 separate pieces. Both of these terms in the numerator can both be written over the denominator, separated by a subtraction sign. So I just took 1 over cosine x minus cosine x over cosine x. That's breaking apart. Normally we don't do that. Normally we don't break apart the fraction. Usually we want to combine it and put it together. But I'm doing this because the left-hand side has 2 separate pieces. And I notice that I have a 1 over cosine x and a 1 over cosine x. Now I have to figure out, is there any way that I can rewrite 1 so it looks like cosine x over cosine x? Or I could work off of this right-hand side. Is there any way I could write cosine x over cosine x to look like 1? Well, I definitely can, because it equals 1. So I can go through that and I'll leave now the left-hand side alone, and I'll adjust the second half of the right-hand side. Well, I got to that answer, I got them both to look exactly the same in 2 steps, whereas in the first problem, it took me a little bit more. Oops, I don't want to do that. Took me a little bit more time, not a whole lot, 1, 2, 3 steps, but it took me a little bit more work to do it. And that's how they're going to be. Some will come quick, some will take a while. Some are going to take definitely longer than others. Okay? So, number 3. Now, here's a situation where if I remember certain things, I can rewrite my problems using all of the other identities. So secant squared, I recognize that, and 1 minus tangent squared, that looks familiar. Are those things that I had here? Oh, this is 1 plus tangent squared, and secant squared minus 1. Again, I don't really have exactly what I want to work with, so what I'm going to do is I'm just going to do what I suggested in the beginning, and that is take this and write it in terms of sine and cosine, and then mess with things that way. So secant squared is 1 over cosine squared over 1 minus, and then I'll rewrite tangent squared as sine squared over cosine squared, and then equals 1 minus cosine squared, or sorry, 1 over cosine squared minus sine squared. Now I want you to look at this. In that last problem, I was able to break the numerator apart into 2 fractions. I cannot break the denominator apart into 2 fractions. So this is not the same as 1 over cosine squared minus 1 over sine squared. It doesn't work that way. You can't break apart the numerator. That's the common denominator it has to stay, but you can break apart the denominator. Okay? Right. So now I'm thinking of all the different things that I can do, all the different options that I have. And I know when I've got fractions and fractions, and this one's got kind of a lot of stuff going on. I recall from my maybe 7th grade days, proportions. I can cross multiply. I can do cross products. And so I'm going to multiply the numerator of one by the denominator of the other and do the same thing on the other side. Okay, so this is cosine squared x minus sine squared x over 1. I'm going to multiply the numerators. Cosine squared x minus sine squared x. And then I'll multiply the denominators over cosine squared. Equals, and then this next one, I'm going to do the same thing. Well, 1 times that is itself. Okay, and so now I'm going to take a look. Again, I've been throwing out a lot of different things. One time I divided fractions. One time I broke apart a fraction. Now I'm using a proportion, because these are all math things that are legal to do. Now I recognize, hey, I bet I could break this down just like I did in problem number 2. I could write this as cosine squared over cosine squared minus sine squared over cosine squared equals 1 minus sine squared over cosine squared. And hopefully you're thinking, oh, wait, I see it. And as you get better and as you get quicker at it and more comfortable with this, you're going to get there. You're going to get, oh, I can see it coming together. What's cosine squared over cosine squared? 1 minus sine squared over cosine squared equals 1 minus sine squared over cosine squared. Okay, so now I got it to look exactly the same. Here's my final answer. Sometimes people say to me, well, how do I know that I can do that? Well, you just have to be able to work through all your algebra rules. If it's legal in algebra, if it's a legal way of simplifying, it's legal here. And so I can do anything that is mathematically legal. You kind of have to sort of remember how things work. Okay, so speaking of things that I can do algebraically and things that are legal, I also have things like distributive property that are an option. So if I see a function, a cosecant here outside of a parenthesis, I can go ahead and I can distribute that through. I don't have to, but I can, and I want to. And I'm going to show you how that works. So I'm going to multiply the cosecant to each part. Cosecant x times 1 is cosecant x, minus cosecant times cosecant is cosecant squared x. Now I see another spot where I can break apart a fraction. So I'm going to write this as sine x over sine squared x minus 1 over sine squared x. Now, one of the things that I suggested that you do is that you rewrite your original problem in terms of sine or cosine. Remember, that's not the rule. It's a suggestion. And so in this particular problem, I'm going to leave the cosecant x minus cosecant squared x, and I'm going to work off of this other side because I'm starting to see something. I notice that I can cancel out a sine x from the top and on the bottom. So that leaves me with 1 over sine x minus 1 over sine squared x. I left this side the same, so I'm going to rewrite that. Okay, and then I'm going to, again, take a look at this. Well, if we look at the reciprocal function, what is cosecant x equivalent to? It's equivalent to 1 over sine. So what is 1 over sine equivalent to? It's equivalent to cosecant x. Likewise, what is 1 over sine squared? Well, that is cosecant squared. And doesn't it look like the other side? So again, just keep working your way through and seeing if you can come up with something or make it, manipulate it. You are a manipulator here. Work your way through and get the two sides to look the same. I want you to pause the video and try number 5. Now, there are going to be multiple ways to do this, but pause it and see if you can get through number 5, see if you can figure out an answer for that one. And then when you're done, put it back on and take a look and see what I did. See how yours compares with mine. Remember, you're not wrong if yours doesn't look exactly like mine. The goal is that the bottoms, when you're finally done, your two sides should be exactly the same. All right, so take a moment, pause the video, and I'll talk to you in a few. Okay, so what I did is I went back to my original suggestion, which is write everything in terms of sine and cosine. So I rewrote the secant as 1 over cosine, cosecant as 1 over sine. And then sine and over cosine I left on the right-hand side as is. Then you could have maybe divided these fractions, so flipped and multiplied, because I did that in the first problem, but I went ahead and used that proportion option again. So I multiplied diagonally. I multiplied cosine times 1 over cosine x and sine x times 1 over sine x. And so I got sine x times 1 over sine x became sine x over sine x, because remember that's sine x over 1. Multiply the tops, multiply the bottoms. And then the other side became cosine over cosine. Well, when the top and the bottom match, they are equal to 1, and so I got both sides to be the same by making them look like 1. All right, I'm going to do just one more with you, and then I'm going to have you work on your homework. Your homework will be 3 evens or odds. You're going to give these a try and come with lots of questions. I'm going to do one more, and then we'll do some practice with more of them in class and see how you do on your own when we put those together in class. So this is a 1 plus tangent squared. And so again, I'm going to go back to that first page because again, I feel like I remember seeing that right here, 1 plus tangent squared or tangent squared plus 1. That's the same thing because addition is commutative. That's one where I can go back here, and that means that I can rewrite 1 plus tangent squared as secant squared. So that's secant squared over tangent equals 1 over sine cosine. And I don't have everything in terms of sine and cosine just yet, so maybe I'll try and do that right now. So I'm going to take the secant squared, and I'll rewrite that as 1 over cosine squared over sine over cosine equals 1 over sine cosine. So I used a different step here to get that simplified. Again, I could have broken this down. That's not the only way to do it. I could have broken this down like you've seen me do before. Or you could cross multiply right away from at the beginning. You've seen me do a proportion before. I was just jumping in. This is what I felt like I wanted to do on this one. Not one exact right way or wrong way. But in this next problem, what I think I'm going to do is I'm going to do that proportion cross product here now. I have to move this one up and over. So I'm going to multiply sine x cosine times 1 over cosine squared. That'll give me sine x cosine x over cosine squared. And then on the other side, I'll do that cross product. That would be sine over cosine. And maybe, again, you're at a point where you see something. It's always a good feeling when you're like, oh, I see something, I see something. Can cancel out a cosine. So that's going to leave me with 1 cosine on the bottom, because I had cosine squared. So this is sine x over cosine x equals sine x over cosine x. Okay, so like I said, a little bit different, and it takes a little while to get yourself comfortable with or used to doing this. Takes yourself a little while to learn what the rules are, but as long as you follow mathematically the rules, if you do things that are legal in algebra, you will be doing things that are legal in this particular section as well. Your goal is to get the two sides to look exactly the same. There we have it. I'd like you to try 3-3, evens or odds. And like I said, come with questions tomorrow. And in our time together in class tomorrow, we will go through and work through these problems, the rest of the problems, talk about different things. I'll get your input on things, and hopefully it all comes together for you. So I will talk to you soon. I hope you guys have a great day.